The moon, our little companion, our only friend in the big, dark, cold space. It's not surprising that any events related to it, like solar or lunar eclipses, excites us. But how about the black moon, the blue moon, a supermoon? Have you ever heard of them? Well, let me tell you about it and how you can observe them. Let's get your calendars ready. The distance between the Earth and the Moon is 238,900 miles, I've measured. Feels not so far, doesn't it? But trust me, most people greatly underestimate this difference. Did you know that every planet in the solar system, including Jupiter and Saturn, would fit between the Moon and us? Yeah, I couldn't believe it myself. The Moon is tidally locked to the Earth. That's why it's always turned to us with only one side. There are a few phases in a lunar cycle. The new moon is the first phase. The sun illuminates the unseen side of our satellite, so we can't see the moon. It's almost invisible in the sky. The rising moon is the gradual growth of the light part. The full moon is the phase during which the sun completely illuminates the visible side. The descending moon is a gradual waning of the light part. And finally, another new moon, and the whole cycle starts again. There are 29.5 days in a lunar cycle, so it takes around a month if we're not talking about February. But why am I telling you all this? So you can better understand Black Moon, a rare astronomical event that happens once every 29 months or 2.5 years. This term doesn't exist in astronomy, as it was made up by astrologers. It's unofficial and has several meanings. Black moon may mean the second new moon in a month. Usually there's only one new moon per month, so having two is a rare phenomenon. It's caused by a slight discrepancy between the lunar cycle and the Earth's annual one, something like leap years. Black moon can also mean something else. For example, usually there are only 3 new moons per one season. Basically, one new moon every 30 days. However, if there are 4, the black moon means the third one. There are also some less popular meanings. For example, that's what people call February without a new or full moon. This happens about once every 19 years. But what's so special about it? The satellite is wholly hidden in the sky during a regular new moon. But during a black moon, you'll be able to see its dark silhouette. You'll have to choose a good place without city lights. If you live in a big city, you'll hardly be able to see it without a telescope. Also, since the sky turns black during this phenomenon, you'll be able to see different constellations that were hidden before, as well as Jupiter and Venus. The last time this happened was on April 30th, 2022. You could observe it in most parts of the United States, except for areas in the Pacific, Alaska, or Hawaiian time. Aloha! Yeah, unfortunately, if this is the first time you hear about the black moon, you've already missed it. Now you'll have to wait another 2.5 years. The next black moon will happen in September 2024 by standard definition and May 19, 2023 by seasonal definition. But hey, don't worry. You can always see another astronomical event once upon a blue moon. Now, I'm not mocking you, I'm being serious. You can still see the blue moon. Well, not literally, of course. The moon won't turn blue. That's just what astrologers call the second full moon in a month. The black and blue moons are similar by definition, but they're actually the opposites. If the black moon is a rare second new moon in a month, the blue moon is a rare second full moon. They also both happen every 29 months. Not so rare, right? Kind of ironic that this event was called the blue moon. Folklorist Philip Hitchcock assumed that the calendrical meaning of the term blue moon was first invented by the Maine Farmer's Almanac in 1937. Now, another interesting astronomical event is called the supermoon. Stock up on telescopes and look for some hills, because you'll see an exceptionally bright and large moon, like the one we only see in movies. What exactly does a supermoon mean? You see, the moon doesn't revolve around the Earth in a circular orbit. Its orbit is elliptical, and the place where it's closest to the Earth is called perigee. A supermoon is a phenomenon that occurs when the full moon coincides with the perigee. Because of this, it seems to us especially large and bright. It looks 14% larger in diameter and 30% brighter than usual. By the way, this phenomenon is often confused with the so-called moon illusion. During the moon illusion, the moon is low above the horizon and visually appears larger in size. Of the 12 or 13 full moons in a year, 3 or 4 are supermoons, but most of them are not very significant. You probably won't see a difference at all. The most interesting ones are the rare large supermoons. During them, the moon actually becomes big. The last major supermoon occurred in 2016. Unfortunately, large-scale supermoons are rare and occur about once every 18 years. The next one will happen only in 2034, but we can observe smaller supermoons quite often. In 2022, they'll take place on June 14th and July 16th. There is also an opposite phenomenon called the micromoon. You've probably already guessed what that means. It happens when the full moon is at its farthest point from the Earth. This point is called apogee. The next micromoon in 2022 will take place on June 29th. In 2023, we'll be able to observe it on January 7th, February 5th, and August 16th. Of course, you don't have to follow each of these events. Most people are more interested in lunar and solar eclipses. By the way, are you one of the people who confuses these two events with each other? Test yourself. Pause this video, describe what these two eclipses mean. Let's compare your answer with the correct definition. Are you back? Okay. So, a solar eclipse is a phenomenon where the moon entirely or partially covers the sun. A solar eclipse is possible only during the new moon when the moon itself is not visible. Many people believe that this event is incredibly rare, but this is not quite true. A lunar eclipse is a phenomenon in which the moon is entirely or partially in the shadow cast by the Earth. The lunar eclipse can only happen during the full moon when the proximity of the moon is on the node of its orbit. If you guess right, well done. If not, hey, don't worry. Many people confuse them. In 2022, a partial solar eclipse will occur on October 25th. It'll be visible in Europe, South and West Asia, North and East Africa, and the Atlantic. As I mentioned, a total solar eclipse is not as rare as many people think, but the problem is that it's not always visible from any part of the planet. So, if you want to see this event, be sure to look for their calendar and see from which parts of the Earth you'll be able to see it. And don't forget the special glasses. Lunar eclipses occur much more often, though. Partial lunar eclipses happen almost every month, but the total lunar eclipse in 2022 will take place on the night of November 7th to 8th. You'll be able to see it in almost all parts of the world except Africa. I hear that the zebras are not happy about this. The moon is a genuinely fascinating satellite. You think whatever, it's just a small rock ball. But in reality, there are so many interesting things connected to it. What rare lunar events have you seen or want to see in your life? Have you observed any rare and interesting astronomical events? Be sure to share in the comments.
Our sun is insanely massive. Want some proof? Well, 99.86% of all of the mass of the solar system is in the mass of the sun. In particular, hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks that threaten to damage their spacecraft. Sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that a chance of collision is next to nothing. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that has been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. While looking up at the stars through your kitchen window, you ask yourself, could you send pizza to space? And more importantly, could you still eat it if it came back? These are some mighty important questions. Okay, focus. How are we going to send the pizza to space? Given that NASA's first space shuttle cost roughly $49 billion, I don't think they'll allow us to borrow a rocket ship for the day, since they may have, more important things to do. Without our rocket ship, we won't be able to get the pizza that high, or to travel at that speed. Okay, fine, they can keep their rocket. I'm happy with my amazing weather balloon, which, by the way, will still get us a third of the way to space, bringing us to the area known as the edge of space. Given that the atmosphere up there is so thin, about 1% of the pressure at ground level, it's really not that bad of a substitute for actual space for this test. I was never comfortable with being that far away from my dinner anyway, so this works much better for my food abandonment issues. To ensure we could find the pizza once it landed, we attached radio trackers to it before launching. These send a signal with a GPS position to the ground, which is then put on a map for us to chase, giving us a good idea of where the pizza will be found. Oh man, I love technology! And just like that, the moment has arrived. We found our pizza intact, and after some moments of passionate hugging and loving strokes, I'm ready to take a bite. So, was the wait worth it? How does it taste? And can you eat it? Yes, you can. But the taste? Not that great actually. And despite mentioning it earlier, I forgot to bring my microwave. The crust's been frozen from the frightening temperatures experienced on its journey. And I actually mean frozen. The bread itself has an icy middle. But before we can even discover this, we'll notice that when we go to rip a piece of the pizza off, it doesn't tear as normal. Instead, it snaps off, as if we've just broken a piece off a twig. We can even hear a clicking noise. My warm, soft bread is no more. You'd be better off keeping this for dessert, in the event you run out of frozen ice cream. On second thought, let's just throw it in the trash. Nonetheless, it's pretty cool that we were able to send this garlic bread to the edge of space and still end up eating it, right? We all know the Earth has one moon, but there are two more asteroids, 3753 Cruithne and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it's looking like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one follows a horseshoe orbit around our planet. Its specific path brings this asteroid closer to us every 95 years. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. A recent study claims that the Moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the Moon's surface and further into space. For several days each month, the Moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full Moon's diameter. You won't believe it, but the Moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the Moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Turns out, there are plenty of planets in the universe and even in the Milky Way galaxy that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight, they're gonna let it all hang out. Or something. Our moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the moon's poles, especially the South Pole, you'd see such shadows all over the place. There are tiny cold traps, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness, and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny, but still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the moon. One theory says a huge part of the lunar surface could have the capacity to store water, but no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue.
It's 2065, and you're standing on the moon's dusty surface, working away on the latest array of solar panels to help fuel the local town's energy grid. Suddenly, the surface begins to shake. Is this a moonquake? Or are those moon-born teenagers having a party in the town hall again? You look up at Earth. You're so used to it, you barely even notice it anymore. But now, it looks different. It takes you a few moments to work out why. It appears to be shrinking. You begin to panic. The Earth is moving away. The ground rumbles again, and you work out what's happening. The Earth isn't moving, but what you're standing on is. The moon has broken off its orbit and it's heading out into deep space. Destination unknown. The strange thing is, it's happening right now and has been for a very long time. It's even affecting how long our days are. Eventually, it will pull away altogether and dramatically affect our planet's oceans. To explore what will happen, let's go back a little to put it all into perspective. The moon has been hanging around us, literally, for 4.51 billion years. There are a few theories as to how the moon came into being. The main one is that it formed when a large object smashed into the young Earth. The early solar system was a chaotic place. A number of stellar bodies were created that didn't make it into a full planet. One of these bodies, as large as Mars, smashed into Earth, throwing huge chunks of our planet's crust into space. Gravity took over and tied these separate elements together. This explains why the moon is made of lighter particles than we find here on Earth. Billions of years later, and we're more than used to having the moon with us. It affects so much of our everyday life. The obvious one is tidal motion. The gravitational pull or tidal force that the moon exerts on our planet creates the tides. This force causes all of the water on the Earth's surface that's closest to the moon to bulge out to one side. A very short explanation is that it pushes in from the top of our planet and also the bottom, while pushing out from the sides at the same time. The Earth also has an effect on the Moon, which we'll get into in a minute. But it appears that the Moon might not like our company as much as we might think. It's slowly drifting away from us, even as we speak. The Moon can seem small or large depending on the lunar cycle, but in actuality, it's just over a quarter or 27% of the size of Earth. The diameter of the Moon's orbit around us is nearly 477,213 miles, but this diameter is increasing by 1.5 inches every year, which of course means that it's moving away by a factor of 1.5 inches each year. To help explain why we have to analyze our relationship to the Moon a bit more closely, both celestial bodies are tidally locked. We are synced up in such a way that we always see the same side of the Moon. The hemisphere that we never see is often referred to as the dark side, but that's not quite right. As the Moon orbits Earth, different parts are in sunlight or darkness at varying times. This change in illumination is the Moon going through its various phases. The tidal forces not only affect our oceans, but the body of the Earth too. Because the Earth is more rigid in structure than water, the tides on more solid matter, like the Earth's crust, have a much smaller effect. The tidal forces are interdependent. The gravitational field of the Earth will also apply tides in the body of the Moon. Again, because we're not talking about fluid, the effect is very small, but it's there. This interchange of tides is quite complex. Interiors of both bodies are heated by these tides, just as the force applied to any object can create friction or its own heat. Take the planet Jupiter, for example, and its moon, Io. The tidal forces of the giant planet are so huge that the surface of Io, which is solid, is raised and lowered several hundred feet in each rotational period. The heat generated means that the interior of Io is most likely molten. As a result, the surface of Io is covered with active volcanoes. It's one of the most geologically chaotic places in our solar system. Despite its heat, it's definitely not the place to take the family for a summer holiday. Back to Earth. Our planet rotates on its axis once every 24 hours, and the Moon performs one revolution around us in 27.3 days. The bulge on Earth actually speeds up the Moon. The Earth pulls the Moon ahead in its orbit. In other words, the Earth's bulge increases the radius of the Moon's orbit around us. While this is happening, the Moon pulls back on the tidal bulge of the Earth, slowing its rotational speed, though just a fraction. A very small fraction. This means that 100 years from now, a day on Earth will be 2 milliseconds longer than it is right now. Blink and you'll miss it. Literally. In addition, since the Earth is larger, the gravitational pull is stronger, causing the Moon to speed up slowly. As time passes, its orbit will become bigger and bigger. This takes us back to that measurement of 1.5 inches. It may not seem like a lot, but over a period of time, this measurement becomes significant. Let's jump forwards billions of years from now, where we see that the Moon's orbit is so big that it does leave the pleasure of our company permanently. What happens to our oceans then? You've already guessed it. The tides will cease to be. That will make for very calm seas for any boat trips. That's if there are any humans left in, 50 billion years. Before that time, because of the tidal locking slowing down the Earth's rotational speed, it's possible that the Earth will slow down enough to permanently face the Moon. In turn, it may prevent the Moon from moving away from us. Imagine the effect on our planet if we stop rotating. One half will always be in darkness, the other in light. That'll play havoc on our seasons and the natural life. While it sounds dramatic, and the loss of tides would be a significant phenomenon, there are other more serious things to worry about occurring before then. In a tenth of that time, 5 billion years, our sun will likely consume both the Moon and the Earth. Yep, our sun is going to have a galaxy-sized party, the likes of which our solar system has never seen, and everyone's invited. The sun is continually burning the hydrogen in its core into helium. Right now, it's approximately halfway through its life cycle. Towards the end, it will run out of hydrogen in its core. The sun will ultimately become a red giant. Its surface is predicted to reach Mars. That's when gravitational forces will take over. The Earth will be dragged into this new sun and disintegrate. The sun gets 10% brighter every billion years. So long before the planet is totally destroyed, the heat will have melted any ice and fried almost everything living. All of our oceans will have dried up too. So, while the planet has a 5 billion year life cycle yet, everything living on it may only have a billion. To recap, the moon may move from the Earth, but the sun will have wiped out both long before the tides are halted. Let's steer away from that hot object and return to that sibling-like relationship of the moon and Earth. The fact that the moon has the same rotational period as the orbital period of both the Earth and the moon is no coincidence. Over billions of years, the tidal coupling of the two has led to the synchronization we know today, and yet it's still evolving. The Earth is slowing its rotational period. Eventually, it will match that of the moon, and they will be exact. And as I mentioned before, the days on Earth will become longer as well, by 2 milliseconds every century. To have a significant impact, it will take many thousands of years. However, it's nice to think that both the Earth and the Moon affect each other in many powerful and beneficial ways. It's almost like they're simply hanging out together, like a couple of old intergalactic buddies.